Hello and welcome to today's physics class. We're looking at a quick revision. We'll solve some past questions involved in resistor. So let's try to solve this particular question under resistor. It says consider the following circuit and complete the table. So I have this circuit here. I have R1, R2, R3. This being arranged in this pattern. I have a 12 volt here. So I'm asked to fill up this, complete this table. So I'm asked to fill up these spaces here, right? So what do you do first? First is first. My first task is to find my R equivalent or perhaps total resistor, right? So R1 is 150. That's 150 here. R2 220. That's 220 here. R2 220. R3 is 470. R3 470 as you can see. So let's find the equivalent. So our first task here in this case is to try to get R equivalent, right? So look at this place. Look at this place. This one here. If you observe R1 and R2, for those that are already following my classes, you should have known when resistors are in series and when resistors are in parallel. You should know, you should differentiate it, right? I will assume you know that. So if you don't know that, I'll leave a link to the introduction to resistor in the description of the video. So check the description of this video or check the video description. I'll leave a link to the video that will teach you how to go about the concept of resistor from scratch, right? So for this case here, observe that R1 and R2 are in series, right? Because the series is simply the end-to-end. So this is an end-to-end connection of the resistor. So in this case now, I want to find my R equivalent or my total R total. I want to get R total now. In this case now, we said since R1 and R2 are in series, so for series arrangements, when you have a series arrangement of a resistor, what's the formula? You should know that. So let me call it R12 is equal to R1 plus R2. So let me call the equivalent of R1 and R2. Let me call it R12. Because if you observe that we are told to find R total, I can't say that R total is R1 plus R2. Observe that there's still R3. So that's not my total, right? So R1, R2 gives you R12. So the equivalent of R12 is R12 is R1 plus R2. So because they're in series, I have to plus it. If they were in parallel, I would have said 1 over R12 equal to 1 over R1 plus 1 over R2. This is when resistors are in parallel. But in this case, they're in series. R1 and R2 are in series. So for them to be in series there, I have to add them up in this format. Alright. Proceeding, the equivalent of R12 is equal to what's R1? Of course, 150. 150 plus what's R2? Of course, 220. 220. The equivalent of R12 is equal to add 150 plus 220 there. I have 370. This gives you 370 ohms as the value for R12. Now observe that I combined R1 and R2 together. It gives me R12, and the value is 370 ohms. So it means that if I should redraw this diagram, I should be having this, please observe. Observe this, please. So yes, it's this R3. Yes, R3. R3 is of course 470 ohms here. So I combine these two together to form one, and that one is called what? R12, and R12 is what? 370 ohms. Now observe that R12 and R3 are connected in what? In series. By the way, I have a 12 volt here. This is a 12 volt. So just like that, this end moves this way to this end. This is an end connection of resistor. This man are still in series. So I'm saying that R12, and R3 are in series. R3 are in series. If this man are in series, what do we know? We know that, so in this case, observe that after R12 and R3, there is no other resistor here again. So becomes what? Becomes my R total. So R total, all right, at this point here, let's get, so observe that if I combine R12 and R3 together, there is no other resistor in this circuit again, because my R total, so, or R equivalent if you want to. So my R total is equal to R12 plus R3. This man gives you, what's R12? That's 370. So that's 370 plus R3 is of course 470. That's 470 ohms. Combine this together, my R equivalent or R total is equal to 370 plus 470 there. I have 840. So I have 840 ohms. So my R total is 840. All right, I've gotten my R total. Let's now get voltage for each of them. Let's get voltage for each of the resistor. All right. From here, please, we'll get voltage. Let's try to get current first. Before we look for voltage, let's get current first. You know why I say it's get current first? Because it's easier to get. Whenever resistor are in series, it means that they are sharing the same current. So when resistors are in series, it means the same current flow through them. All right, let's move to the next part there. Calculating for current. Let's do current calculation. Let's do current calculation, please. From here, calculate for current. Calculating for current. So when it comes to, that's I, current is I, right? So said. So note this, please. Very important, please. Note, please. Note this, please. Whenever resistors are arranged in series, the same current flow through them, please. The same current flow through them. That's important, please. So it means that my I1, I2, I3 will be the same. Why? Because for series arrangement of resistor, we expect the same current to flow through them. Now, here's the idea, please. How do I get current here? So from Ohm's law, we said that V is equal to IR. This man is Ohm's law. In general form, voltage is given, that's 12. My I is what I'm looking for. Why this R here? This R here is not R1, is not R2, is not R3. It is my R total. So in other form, I have that V equal to IR total. From here, make I subject here. I will be equal to V over R total. Let's get I. This man is equal. What's V? V is 12. 12 over, what's R total? That's 840. 840. Divide this man. Note that the current flowing through this series resistor is equal to 12 divided by 840. I have 0.014. Of course, current is in ampere. That's ampere. So if my I is equal to 0.014 ampere, it means that I1, so it means that R1, for I1, because R1 is corresponding to I1, it means that my I1 will have the same value. I2 the same value, I3 the same value, and R total the same value, right? So the why are they the same value? Because we said when resistor and in series, the same current flow to them. So I'm saying that I is equal to I1 equal to I2 equal to I3 equal to what's the value there? 0.014 ampere. So I'm saying this, please. 0.014 ampere. So my I1 is 0.014, I2 0.014, I3 0.014, R total 0.014. All right, this is the value for current. Let's get voltage for each of the resistors. Let's do voltage calculation. Let's do voltage calculation. Let's do voltage calculation. All right, let's work on voltage calculation there. For this one here, voltage calculating for voltage. All right, in bracket V, I'm still going to apply the idea of Ohm's law to solve for get voltage here. So what do we know? We said voltage V is equal to IR. This man is from Ohm's law. If it is true, how do we get voltage? So let's get voltage at each section, right? Yeah. From here, let's get V1. So for voltage at section 1, V1 is equal to I in brackets R1. Perhaps IR1. Perhaps I can say I1, I1, R1. But we know that I is the same all throughout. So I can say I times R1. So V1 voltage at section 1 or at this column here, my voltage here is equal to I 0.014 times R1. What's R1 there? Is 150. 150. V1 is equal to 0.014 times 150. This man gives you 2.1 volts. So my first vote V1 is 2.1. Let's get V2. Let's get V2. So we said this is V1. For V2, I have V2 is equal to IR2. V2 here gives you I is constant. That's 0.014. 0.014 times what's R2? R2 is of course 220. That's 220. Multiply this, please. V2 gives you about 0.014 times 220. This one gives you 3.08. Perhaps if you want to one decimal place, 3.1 volt. So my vote here gives you 3.1. Finally, let's get V3. For V3, what do we know? V3 is equal to IR3. This man is Ohm's law, right? Same concept. V3 gives you I is of course constant 0.014, 0.014 times R3 gives you 470. 470. In essence, my V3 here is equal in value to, if I multiply 0.014 by 470 there, I have 6.58, approximately 6.6 volts. So my V3 is 6.6 volts. So if I add everything together, I'll have either 12 or approximately 12. Please. So this is how this works. Finally, let's get the power for each of the resistor. Right? Let's get the power here for each of the resistor. So let's do calculating for power. Calculating for power. Let's do power calculation in brackets P. Alright, for each section, I have section 1, R1, R2, R3. So I'm going to calculate for power in terms of R1, R2, and R3. What do we know before now? power is equal to I times V. Alright. Power is the product of what? Current and what there? And voltage. Express this man in terms of 1, 2, and 3. So let's work on R1 first. Let's get P1. So P1 is equal to what there? IV1. This man gives you, what's I? Is constant. This man here is constant, right? That's 0.014. That's 0.014 into what's V1 there? 2.1. That's 2.1. Here's the idea. Here's the idea. Power can be expressed in this form, but I don't want to use this form because if you observe that the currents are similar to each other, right? So I can still say that power is equal to current I into what's V from Ohm's law. V is what? IR. We know this. So whenever I see V, I can put what? IR. I see V now is IR from Ohm's law. Then it gives you what there? I square R. I can still use this. So either using this format or this is still the same thing, please. So okay, to save time and stress, let's use this concept, right? I can still use this or this formula. Say the same thing, please. So P1 is equal to multiply this 2 times 2.1. I have this one gives you 0.03 watts. So P1 is 0.03 watts. Next up, please, let's get P2. P2 equal to IV2. IV2. This man, I is constant. That's 0.014. What's V2? V2, that's 3.1. That's 3.1. This man gives you P2 is equal to, multiply this together there. 3.1. I have about 0.04. That's okay. 4 watts. So this man gives you 0.04 watts. Next up there, let's get P3. From here, all right. P3 is equal to IV3. 0.014 times V3 is what? V3 V for 3 6.6. 6.6. So my P3 is equal to 0.014 times 6.6. This man gives you 0.09 perhaps watts. So this man gives you 0.09 watts. Finally, let's get for power total, because it's R total. So the total, let's get total there. So power total is equal to I total times what? V total. P is I V3. So like P is IV. So P is still IV, but in form of total, because I am under total column. So P total is equal to, what's I total? My current total is this value, 0.014 times what's V total? V total is what? Is 12. So times 12. My P total here is equal to times 12. This gives you 0.1, let's say 7 approximately. Voltage. Sorry, watt, please. Power is watt. Alright, so this one gives you 0.17 watts. This is how to fill up this table. As you can see, I show you guys the step-by-step procedure on how to fill up this table. If you found this class helpful, do it to like this video, leave a comment, share to your friends and classmates, and then I'll see you guys in our next class. Do well to join my channel membership. I'll also leave a link to my WhatsApp channel in the link of this video, so you can do well to join the channel so you get updates on our latest content. So do well to share this video and subscribe to my channel. See you guys in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. I just launched my website www.ghanabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.